A prime number is a number which can only be divided by itself and 1 without leaving a remainder. I have put the first 8 prime numbers up on screen. These are in green. These are 2, 3, 5, 7, 11, 13, 17 and 19. These are not the only prime numbers, but they are the first 8. Let me show you in a bit more detail what makes these prime. If we take, for example, 7 divided by itself gives us an answer of 1, and 7 divided by 1 gives an answer of 7. However, we cannot divide it by any other numbers to give a whole number answer, like we got here with 1 and here with 7. Let's take another example. 13. 13 divided by itself gives us an answer of 1, and 13 divided by 1 gives us an answer of 13. However, once again, 13 cannot be divided by any other number, or your answer will be a decimal. This is different to the numbers not in green here, for example 14, because whilst 14 can be divided by itself and by 1, it can also be divided by 2 and 7, which means 14 is not prime. So, you can't divide a prime number by any number apart from itself and 1 to give a whole number answer. And therefore, what we can say is that the prime numbers only have 2 factors, themselves and 1. And a factor is just a number which divides another number equally, so without a remainder. Let's look at some slightly larger numbers and decide whether they are prime or not prime. The first number is 27. Now, the easiest way to determine whether or not a number is prime is to list its factor pairs. And these are just pairs of numbers which multiply together to give another number. So in this case, 27. So 27 and 1 multiply to give an answer of 27, but also 9 and 3 multiply together to give an answer of 27. Therefore, we can say that 27 has 4 factors: 27, 1, 9 and 3. And as a result, we know 27 therefore is not prime, as prime numbers only have 2 factors, as we said before, themselves and 1. However, 27 has 4 factors that we wrote down over here, which means that it is not prime. Okay, let's now think about 31. Is 31 prime or not prime? Pause the video, have a think, and then play it again when you're ready. Okay, again, let's think about factor pairs. What pair or pairs of numbers multiply to give 31? Well, only 31 and 1 multiply to give an answer of 31. There are no other numbers apart from 31 and 1 which divide equally into 31, leaving no remainder. Therefore, 31 only has 2 factors, itself and 1, which means that it is a prime number. Okay, hopefully you found those alright. Let's now take a look at some example questions to put this into practice a little bit further. Okay, let's try these questions. Before we begin, it might be useful to look at a number square with the prime numbers highlighted on it, just to familiarise yourself with them. And then once you're confident enough, try these questions. Okay, question 1 says, what is the 4th prime number? I recommend pausing the video, trying it out and then playing it when you're ready. Okay, the best way to do this is to start from the first prime number and count up until we get to the fourth one. Now remember, 0 and 1 are not prime numbers. So the first prime number is 2, the second prime number is 3, the third prime number is 5, and finally the fourth, the one that we want, is 7. So that's the answer to question 1, 7. Question 2 says list all the prime numbers between 20 and 30. Again, pause, have a go, then continue when you're ready. Okay, the first thing that I'm going to do is make a list of all the numbers between 20 and 30, and then we can figure out which ones are prime and which ones are not prime. So an easy rule to apply is that all even numbers are not prime because they are divisible by 2. So in other words, 2 will fit into all even numbers without leaving a remainder. Therefore, we can cross out 22, 24, 26 and 28 because they are all even. So we know that they cannot be prime numbers. Next, we can cross out 25. We know that isn't prime because it's a multiple of 5, so 5 fits into it. Now we're left with 4 numbers, 21, 23, 27 and 29. Let's start with 21. 21 isn't prime because 21 multiplied by 1 is 21, but also 7 multiplied by 3 is 21. Which means 21 has 4 factors instead of 2, so we know it can't be prime because all prime numbers only have 2 factors. Finally, 27 cannot be prime because not only is 27 multiplied by 1 27, but 9 multiplied by 3 is 27. Therefore, it also has 4 factors, and we know that it cannot be prime. As a result, we are left with the 2 remaining numbers, 23 and 29, so we know that they must be our only 2 prime numbers between 20 and 30. So our answers are 23 and 29. Finally, question 3 says, what is the first prime number bigger than 50? To do this, let's start with 51 and go up. 51 isn't prime because 17 multiplied by 3 is 51, meaning that 1, 51, 17 and 3 are all factors, and so we know 51 is not prime. 52 isn't prime because, as we said before, all even numbers are not prime because 2 will go into it. 53, however, is prime because it only has 2 factors, itself, 53, and 1. Therefore, our answer to 3 is 53. Okay, hopefully they were all alright. Let's try a couple more just to practice. Here we have the last 2 questions. Question 4 says, what is the closest prime number to 65? Now to answer this question, we will start at 65 and look at numbers above and below until we find the nearest prime number. So if we start with 66 and 64, we know straight away that neither of these numbers are prime because they're both even, and therefore they both have 2 as a factor. So we can go ahead and cross those 2 out, and now look at 67 and 63. Well, if we take 63, we know that this is not prime, because if you're familiar with your times tables, you'll know that 9 multiplied by 7 is 63, and 21 multiplied by 3 is 63. Therefore, 63 has 6 different factors, and that means that it is not prime, because a prime number only has 2 factors. So we can cross 63 out. However, 67 only has 2 factors, itself and 1, which means that the closest prime number to 65 is indeed 67. Finally, question 5 says, the sum of two prime numbers is always even. True or false? And just a quick reminder that sum means add. So what this is saying is that if you add two prime numbers together, the result is always even. Is that true or is that false? Well, I will put something up that might help. This is a number square with all the prime numbers highlighted in green up to 100. And what you can see from using this is that all the prime numbers above 10 end in either a 1, a 3, a 7 or a 9. And if you add any of these together, you will find you always get an even number, because two odd numbers added together always gives you an even number. Doesn't matter if they're prime or not, it will always be even. So you might think that this is true. However, you can't forget that 2 is also a prime number, and it's an even prime number. Therefore, if we select 2 as one of the numbers, we can make different odd numbers. For example, 2 and 5, they're two prime numbers, but that doesn't give us an even answer, it gives us an answer of 7, which is odd. We could do 2 plus 11, which gives us 13, which is odd. We could even do something like 2 and 43. That gives us 45, which is also odd. So our answer is false. The result can be odd if one of the numbers is 2, but it must be 2. Okay, I hope that was alright. Thank you very much for watching.